A series of powerful successive earthquakes struck the Turkish-Syrian border on February 6th. The first and most powerful was a 7.8 magnitude quake.
This region certainly hasn't seen an earthquake this size in centuries.
Destruction followed as aftershocks hit the region. Then a second 7.5 magnitude quake hit in the afternoon, followed by its own series of aftershocks. In their wake, a humanitarian and economic crisis. Thousands of people are reported dead, and even more are still missing. It's not the first time this region has suffered a violent quake, and it won't be the last. To understand why, you have to look under the surface, where three tectonic plates converge. Together, these plates cause a unique and potentially devastating type of earthquake. The first quake was located here, 11 miles under the town of Gaziantep, Turkey. 11 miles may sound deep, but that's actually shallow for a major quake. The town is especially vulnerable because it sits near the meeting of two tectonic plates. Tectonic plates are massive slabs of rock on the Earth's crust from 10 miles to 160 miles thick that are always slowly moving.
You can take the Earth and divide it up into several large plates that are all moving around each other, and most earthquakes occur at the boundaries between those plates.
This one is called the Anatolia tectonic plate. It's actually a microplate due to its tiny size, and it's constantly under pressure. That's because it's being pressed upward against the Eurasia plate by the Arabia plate. That pressure is squeezing the Anatolia plate westward, where it faces even more friction from the Africa plate, which is also moving upward.
The Anatolian microplate is caught in a vise between the Arabian plate moving to the north against the Eurasian plate, and this small plate is being pushed aside as a result of that motion.
That means the boundaries between the Anatolia plate and the Africa and Arabia plates are trying to slide against each other as the Anatolia moves to the west and the Africa and Arabia move to the east. These borders are called strike-slip faults, and when the friction builds up between the plates as they're pushed in different directions until it's too much, they slip. That's a strike-slip earthquake.
The strain will build up, and finally it will rupture and release all that accumulated strain in a large earthquake.
That's what happened in Gaziantep, resulting in that 7.8 magnitude quake. USGS estimates that the strike slip occurred along about 100 miles of the fault, about 20 miles shorter than most strike slip earthquakes.
These are significant earthquakes for this fault system, and so that is probably an accumulation of 300 to 500 years worth of strain that's built up since the last earthquake.
Experts say the energy released in that slip is comparable to that released during the explosive 1980 Mount St. Helens volcanic eruption. The same thing happened 9 hours later in Ekinozu, resulting in a 7.5 magnitude quake. This one was just 6 miles down. More than 285 aftershocks have followed both quakes. USGS has called the area tectonically active and unstable.
This region is certainly one of the more complicated parts of the world because there are 4 different plates interacting, so it becomes a region with very complex tectonics.
Those complex tectonics are responsible for a long history of devastating quakes, like this quake from 1966 that killed over 2,000 people.
Towns and villages in 19 provinces are almost totally destroyed.
The 600-mile North Anatolian Fault produced 7 large strike-slip earthquakes from 1939 to 1999. And 3 earthquakes of magnitude 6 or larger have occurred within 155 miles of Monday's earthquakes since 1970. But there hasn't been a large earthquake since 1999.
Because this region hasn't seen a large earthquake for a while, it was overdue.
That 1999 quake was a 7.4 magnitude and caused an estimated 17,000 deaths. For now, USGS estimates there could be billions in economic losses.
The biggest thing is the destruction and loss of life, and it's going to take them years for recovery.
But will there be more disruption if the 2 quakes spark a third? Experts aren't sure.
It may put extra strain on some of the nearby faults, or it may relieve some of the strain on the nearby faults. So it'll take some time to figure out whether further earthquakes are more likely or less likely in this region.
But due to the three-plate convergence, it's not a question of if there will be another earthquake. It's a question of when.